few weeks ago, I gave you a call to action, maybe a bit of homework, a bit of an ask. Fork this repo, rewrite it in something. You all heeded the call and ended up rewriting ADL in a couple different languages, which I think is really cool. So, like, we walked through the Zig to Rust conversion that Onst did. I think I have that pronounced correctly. Again, sorry if not. We're going to just walk through these other ones because I think this is an awesome learning opportunity to look at two languages side by side. So quite literally, that's what we're going to do. You have made me switch to dark mode. So please enjoy the fact that I've caved and switched to dark mode, at least for these videos. Hopefully this will be more legible. I find it less legible, but I'm not you. So here we are. Okay, so I have up on my screen two things. I've swapped them a little bit this time. So the Zig implementation is going to be on the right over here, and the Go implementation, spoiler, is going to be on the left over here. So we're going to look at a couple different forks. We have several different languages to go through, so I think this will be a fun little opportunity to go through about 4 different forks that are progressively, to me, more and more interesting. Okay, so the Go one's interesting. Go is a fantastic language. I really, really like Go. I think it's simple. There's no extra dependencies being added here, which is great. Don't know why you would need them. Standard library is chock full of useful things. So this one's fun because this is a language that I know and I'm pretty comfortable with. But looking at this, they do a couple things differently that I might do differently as well. So let's talk through it. So I've got main.go pulled up here and main.zig pulled up here. Worth mentioning, I've done a little bit of updates to this. So by the time that they forked this and maybe rewrote it, there might be some things that are different or missing. I wish I had a better way to compare those side by side, but I don't. So here we are. So again, just going through this, the Zig version. Let's walk through the Zig version really quickly one time, and then we won't go through it every time that we look at another example. So we pull in the standard library, we pull in this dependency called Zig datetime because datetime formatting in Zig is a little wonky. I have some embed file calls here. So this built-in embeds a file as a string and lets us use them. So we have 4 that we're using. It looks like they actually have 4 as well. So it might be closer than I expected. I'm using enums here. So I've got a command enum called regen create help or unsupported. This maybe instead of unsupported could be null potentially. Someone left that on a comment on a different video where I was using enums and saying unsupported maybe isn't the best option and make it null instead. So I don't know. I need to figure that out. We have a function for comparing strings because somehow that's not something that's super easy to do in Zig, or not given to us out of the box in Zig, I should say. A function called read file if exists, so it reads a file if it exists. Otherwise, it returns null. Can also return an error, worth mentioning. We have a function for rebuilding the README. It uses the template contents from read file if exists, so it'll try to use your own template if you specify one, or else it will use the ones that are embedded. Some datetime formatting. We massage this template contents into output by replacing some mustache style templates with the word timestamp. And then we use an array list here to collect all of the files. We sort those, iterating through those files, formatting the names as markdown, essentially, in this case. And then doing some more string replacement, creating the file, writing the contents to the file, deferring, closing. This is nice, opening and then being able to defer closing it. We'll see that in Go as well, which is really nice. Generate ADR, more or less the same. Just going to highlight some things that are interesting here. So this is a really nice way to add prefix zeros or left padded zeros to a number. Zig gives us this through the formatting package, which is really, really nice. Some more printing for formatting purposes. Similar, read file if exists, or else use the contents that are embedded in the binary. We essentially try to create a safe name based off of the ADR name that you've passed in. So we remove some certain characters. Creating the file, deferring, closing it, writing the contents. We're almost done. Establish core files, gets the current working directory, makes some paths based off the current working directory, makes a file based off the current working directory, and then writes the template README contents into the README. a function for getting all the files in the ADR directory. This opens that directory, iterates on it. We defer closing that because good behavior. We create an array list here to hold these files. We iterate over the directory. And here's actually those iterations. So we're checking if essentially the entry name is README, assets, or templates. We don't want it. So if it's not those, then we append it to the file list and we return it. Our main method here is essentially grabbing our allocator, deferring, deinitializing that, getting a generic allocator from the debug allocator, because we're going to use that generic allocator and pass it around. We actually set up an arena allocator here. So we wrap that allocator with an arena, and then we defer deinitializing the arena. Without going too into details on this, actually, most of you are Zig viewers, so you probably know what an arena allocator is, but just in case, and I won't go too in depth on this, but the idea here is essentially that arena allocator allows you to allocate a bunch of things into a segment of space and then remove all of the memory that's allocated in that segment in one easy go. So basically you allocate things into the arena and then you deinitialize the arena and it frees up all the memory that was allocated as a part of that. Okay, some arg processing here, standard out, standard error, getting a hook on those writers. We check to see if there is an action. If not, we have it set to an empty string. And then we call meta's string to enum right here. We pass in the command enum, we pass in the action, which we get right here. Or else we have unsupported. And then finally we switch. So if it's create, we do all of this. If it's region, we do all of this. And if it's either unsupported or help, we do all of this. One thing that I did see in a couple different implementations are actual meaningful exit codes. So that's one thing I'd like to do here. So we might see those in some of these as well, some of the forks as well. But yeah, now that you have a general idea of how the Zig implementation works, let's compare. So on the Go side, if you aren't familiar with Go, I've actually, there's one language in here that I'm not familiar with, so I won't be super helpful with that. But if you're not familiar with Go, it's a very straightforward language that is very simple and easy to learn. It's also very easy to read. So if you can read a programming language, you can also probably read Go. Okay, so we have a main package here. We're importing a couple different things. We're importing embed. This is sort of interesting. I don't remember exactly what the appropriate title for this is, but we're essentially importing all of embed and then essentially making it available in this scope. We import fumped. So conversely, like we wouldn't need to prefix anything with embed dot. But here, if we want to use the fumped package, we would do fumped dot println, for example. So we import fumped, which is formatting. We import OS, which is going to be used for files, strings, which will be used for some string stuff, and then time for some time stuff. Set up a couple of different variables here to hold the embedded files. So the way that Go does this is quite interesting. There are these comments, there are decorators essentially that go above the thing that you want to put the contents into. So Go embed as a part of the build will read this file and then shove it into this string right here and make it available. It's very, very similar to what we're doing right over here. It's just comparing the syntax between the two. I'll let you pick which one you like better. We don't need this compare strings function in Go because comparing strings is straightforward. So there's also not a read file if exists. Not sure if that is because this was forked before that was added or what, but please stop showing up. I don't need you, Copilot. So the rebuild readme function here returns an error, or can return an error, I should say. It also could be nil. And all it does is get all of the files in the ADR directory, checks if that returned an error, and if so, it bubbles up the error. This is a very common Go pattern. You also might see people wrapping errors here using something like fumped.errorf, and that essentially allows you to take an existing error and then wrap it in more context based off of where it's being bubbled up. Finally, this returns rebuild readme with files. So that function is right here, that rebuild readme with files. So basically this Zig piece that we have over here is captured via all of this. Which is a little interesting, but Go is maybe a little verbose, especially with the error handling. So this rebuild readme with files here, it takes in a slice of strings, returns an error, and then it gets the template contents. It tries to read the template readme. If there is an error reading it, it sets template contents equal to string temp. That's interesting. This might not be correct. I would expect this to be if the error is, oh, I'm sorry. No, that is correct. If the error is nil. So, okay, if there is no error, then we take what we have loaded and convert it to a string. So this is going to give us what, like a byte slice maybe? So instead we're converting it to a string. Totally makes sense. My bad. We create a new slice of strings called formatted files. Good use of make here. Setting it to the length of files, so the slice that comes in. So we're formatting those like so. So we're ranging over those files using sprintf to print a formatted string. Looks good. And then we're appending them. So again, for comparison, this and this are equivalent. Output's interesting here. So where in the Zig version, I did standard memory replace owned with those mustache templates, they're using a string replacer. This is nice. The string replacer is actually pretty efficient as well. So I think that's a good move. I probably should look for something similar in Zig, but I don't know if there is or is not one. So yeah, this is pretty nice. So you can essentially set up all of the things you want to replace here. So they want to replace timestamp with this. They want to replace contents with this. And then you call replace on it and the string that you want to do those replacements in. Nice thing about this is that where if I am iterating through this multiple times, so like replace owned here is going to have to go through all of these characters and see if there's a match. And then I do the same thing again down here. I'm duplicating that work where this replacer should only go through things once. Okay, and then finally here, they return OS write file. I just, again, realized that this text is kind of small. Let me make this a little bigger. Okay, yeah, that feels better. And then right here, like I said, they are doing os.write file. Here's the path they're writing. They are converting this to a byte slice, which is what it needs to be, and then setting some file flags as a part of the write process. Generate ADR. This one, let's get those close to side by side. So similar here, worth mentioning on the Zig side, we're taking in an allocator because we're doing allocations. In Go, you don't have to worry about that. So besides that, these are fairly straightforward and fairly similar. Generate ADR over here gets the template contents, assigns it to ADR contents, reads the file if it exists, so that template file. And then again, if there is no error, then it sets template contents equal to the string value of that byte slice. So it takes the byte slice, converts it to a string, and then assigns it to template contents. Heading here is doing some more sprintf formatting. I actually didn't know that you could do the zero padding and Go like this, which is cool. I learned something from this. And then it does replace all. This one's not using a string replacer because in this case, we are only iterating through this once. We're only doing a single set of replacements. So, you know, that string replacer might be a little overkill for comparison. We set up the file name, again, doing the zero padding of the ID, I guess would be a good term for it, the numeric ID, and then calls create safe name. So they have essentially a function for creating a safe name, and they're using a string builder here, which is pretty cool. We'll get to that in just a second. Finally, for this method, we do another write file. Okay, let's look at that create safe name. I think this is pretty neat. So it's using a strings.builder in Go. This is essentially a very memory efficient way of building a string with a dynamic amount of characters, or maybe you don't know exactly what those characters are going to be, and you want to build it up slowly through multiple operations. So you can see that we grow the string builder to the length of name. So we get the length of name, and then we grow it, and then we range over name. And we are looking at the characters that we have here, and we're writing replacement runes. So that replacement rune gets passed in here. So in our case, it's a empty string. And if it's not one of those special characters, then we are writing the character as a rune. Runes are interesting in Go. So runes and characters are essentially, there's a lot of overlap, but they're essentially different things. So there are limitations of characters that runes do not have the same limitation of. The short and sweet is that runes are a much more expansive character set, and you can do more things with those. So if you're curious about that, go give it a Google and check it out. Finally, at the end, we return string builder.string. So we're getting a string from the string builder because we need to return a string, and I need to stop clicking on things. Okay, Over here, we have established core files. This is going to be really similar. So we call make dir all, we call make dir all again, and then we write file, and we're writing the README for the templates folder. Pretty similar, actually. Get all files in ADR directory. So over here, we are calling os.readdir. Here's an ADR. If error is not equal to nil, we're returning that error. Again, very common Go practice. Where we have a file list, and that's going to be a slice of strings. It looks like we are appending to that here. So we're ranging over the directory, switching on the entry name. If it's any of these three, so README, assets, or templates, we're just continuing that loop. And then if it is not one of those, then we are appending it to the file list. Finally, we return the file list. There's a couple helpers here. So there's actually just a helper here called assert no error. So this takes in an error and asserts that there's not an error. If there is an error, it prints it to standard error and then gives an OS exit 1. Main method's pretty straightforward. So you can see we check the length of args. If it's less than or equal to 1, we print help contents. Otherwise, we grab the command, we switch on the command here. If it's create, we do all of the creation type stuff that we do over here. Same with regen, and then same with default. Worth mentioning here that they are doing a subslice, I guess is the appropriate term for this, of the args, and are passing, essentially joining those and then passing that as the name, which seems good to me. And then they're also calling that assert no error method all around this. So essentially, if any of these key things have an error, it is printing the error to standard error and then exiting with an exit code of 1. Okay, so that's it. That's all there is to the Go one. There are no other changes from what I've seen. So before we move on to the next one, I just really want to call out VSEI Pelt, Visai Pelt. Thank you so much for doing this. I thought this was really cool to read through this. It sounds like you maybe did too, which is great. So yeah, and also thank you for actually updating the README. I don't think anyone else did. Okay, on to the next one. So this one's interesting. AZJez rewrote it in PHP. For anyone watching in AZJez, you don't have to write PHP anymore. It's going to be okay. It's 2025. You can write other things. That being said, if you do want to write PHP, it actually has gotten a lot better, which was kind of interesting. I went down a rabbit hole of reviewing this code and then seeing all sorts of weird things and having questions and searching PHP documentation and finding that PHP is actually starting to come around to what I would consider to be a pretty decent language. And I feel obligated to mention that Laravel is not PHP. Not that that's related to this code review or code walkthrough at all, but Laravel is actually really nice. PHP, I'm still on the fence on. Okay, so nothing changed here, nothing changed here. So the user-driven templates. So all we really get to look at that's different is we could look at the composer JSON and the composer lock if you were really curious. This is actually kind of interesting. It looks like they're pulling in a library called PSL that they wrote. I don't know what that does. So that's something that we'll probably have to figure out at some point. Also, thank you for keeping my name as an author. That's sweet. But it also makes it look like I've written PHP, which is kind of scary. All right. Good old PHP. We have a shebang up here that is indicating that the script should be executed via the PHP command that you have in your environment. We have a open PHP tag. We're declaring strict types. So this is a declaration you can make that forces strict types, which is one of the nice things to see from PHP. We're putting everything in a namespace called ADL. The capitalization on this feels weird to me. However, that also seems pretty straightforward. So we use PSL, datetime, env, file system, IO, iter, string, vec. These are interesting. So this looks like types and utility functions that are provided by that library that AZJez has built. So if we look again at the composer JSON, you can see AZJez PSL. Let's get back to this. So they're pulling these packages into scope here. We are require oncing the vendor auto load PHP. Man, that takes me back. And then we set up an enum here. So we have an enum, it's a command. Essentially, this enum is a type of string. So we have a case where it can be region or it can be create. Those are the ones that are supported. There are nice comments here too, which is great. Maybe I should do that too. But either way, good move on the comments and the doc strings. Okay, so rebuild README. So we have template contents. We read file if exists. We grab the namespace and we get path from current working directory. So that is find down here. So we say env, we use that env module that I mentioned earlier, and we call current directory. And then we have a vector and we call vec concat, and we concat the vector in this case. So we have a root that we're getting from the current directory and then the parts, and we're adding those two together. Then we call string join on all parts with the file system separator to give us a string back. All right, let's head back up to where we were. So we're reading that there. If the contents are equal to null, nice triple equals, then we get path from script directory, we read that, and then we pull in that template. So we're essentially doing the user template if it exists. Otherwise, we're grabbing the fallback template. Do some date time formatting to get the current date, which is used for the timestamp. I'm doing a string replace on that here. And then we are calling get all files in ADR directory, sorting those. Again, this returns a vector, which is kind of interesting. And then we have a formatted files here, which this would be an array. We're iterating through that using a for each. So for each file as file. We are formatting them and then adding the formatted string to formatted files. Where's that defined? Oh, right up here. Okay. We do string join to do a replacement here with the formatted files. We're essentially adding line breaks in this case, so they're not all on the same line, which is good for markdown formatting. And then we are doing another string replace where we take the contents and we replace it. Let's see. Finally, we get the path from the current working directory, and then we write that file to the path. Okay, there's definitely some helpers here. Instead of bouncing up and down, we're just going to go through it from top to bottom, and we'll get to the helpers when we get to them. They're actually named really well, so you can kind of assume what they're doing based off the names, which is great. Okay, the generate ADR is going to be shockingly more lines of code than the Zig version, which some of it's formatting, I guess, but it's still kind of interesting. So we pad our nums with string formatting here. We have our heading that we're formatting as well. So kind of the exact same thing that we're doing over here. We are following the same pattern where we read the file if it exists. So we're essentially the user's ADR templates, the appropriate template, and then we're falling back on the predefined templates. So I mentioned this earlier, falling back on the predefined templates. The PHP version doesn't embed those files. That's not something that, to my knowledge, is something you can do in PHP since it's a script and it's not compiled or anything like that. So we have to, instead of being able to ship like a single binary where those files are included, to my knowledge, feel free to correct me if I'm wrong, PHP devs, we have to ship the script and then also the templates that come with it. There might be a fun way to bundle that all up. We do some more string replacement here. So we replace the name with the heading. We create a safe name. This one's interesting. So we are essentially replacing, we take a list of characters, or an array of characters, I should say, bind it to as not sure what I've seen this for 15 years and I still don't know the appropriate way to pronounce that word whenever you don't have the full thing. And then we essentially are calling string replace on safe name. So we are, from a performance perspective, while this may be idiomatic PHP, we're doing a lot of iterations here. So we're replacing all of these, and then we're replacing, so the forward slashes, the backslashes, so the colon, asterisk, question mark, double quotes, less than, greater than, and then the pipe. So we're doing 9 iterations. We're iterating through this string 9 times. And then we get a file name. So we get path from current working directory, again, the ADR, and then we do some string formatting here. This formatting's nice. I think, again, that comes from the other package that this person has built, which is interesting to see. And then we call write to file. Okay. So establish core files. This is actually really clean. So we call create directory. We get the path from the current working directory. We throw these two together to generate a path, basically. We do the same thing here for ADR and templates. And then we create a path for the README file. We attempt to read the template that is provided as a part of this project and write that to the README file. Get all files in the ADR directory. This one's nice and tiny. So we read directory here. We grab all the files. We, for each of those, so we're looping through them. We're getting the base name. We're making sure that the base name is not equal to README, assets, or templates. And if that is the case, so if it's not equal to those, then we're adding that to the file list. Finally, we return the file list. Really straightforward. We have a read file if exists function, which is great. That's defined up here in Zig, but you can see that it is pretty similar. So we just do a try and a catch. So we try to read the file, we catch. If we find a not found exception, we return null. Specifically worth mentioning, we're only catching a not found exception. So if you run into a scenario where maybe you don't have permissions to read the file, that could be a scenario that might want to be handled differently here. Or maybe it's fine to let the exception bubble up. In fact, I think that's pretty similar to what I'm doing in the Zig version. That get path from directory takes in, looks like parts, and this is variadic, so it can take in any number of parts, and then concats them using this vector concatenation, and then string joins that. This is the one we looked at earlier for what it's worth. Get path from the current working directory joins the given path parts to the current working directory. So you can see here we're grabbing the environment current directory, doing vector concatenation again, and string joining. Pretty common pattern for this project, I should say. Writing to file writes the given content to the specified file path, truncating it first. So it opens write only, so a write only version of the file. If there's existing content that will be deleted as a part of this write, it locks the file with an exclusive lock, writes everything, releases the lock, and then closes the file. That's nice. That seems well thought out, especially with the locks. Regenerate core files essentially calls establish core files and rebuild README and returns true. Create ADR. Okay, we're on the home stretch here. So we get that string name. If it's empty, we have an error. So we IO write error line. No name supplied for the ADR. Command should be main PHP create name of ADR here. Return false. We establish core files, and then we get all the files in the directory. We generate an ADR for that, and then rebuild the README. Pretty straightforward. Main entry point, fairly straightforward as well. We get an argv array that we're working with here. It never returns, or there's the never return type, I should say, since it exits the script and does not have a return. We get the command name. We try to convert that to an enum. And if the command is null, then we say unknown command and write the help contents, and then exit with a 1 status code. This is actually pretty interesting here. So we have a variable called success, and then we're matching the command, and the result of the matched command's action will get stored in success. So if we do regenerate core files will get stored in success. If we do create ADR, the response of that will get stored in success, which is neat because here we exit. And if it is successful, we exit with a 0 status code, else we exit with a 1 status code. Finally, since this is PHP and we're executing a script, while we have a main method, it's not necessarily going to run the main method unless we call it. So you can see here that we run the main function with command line arguments. This was cool. Some very different things in modern PHP, which is wild to me to see. So this was really fun to kind of go through this one. Hopefully you learned something as well. So I just wanted to thank AZJez for the pull request, or not pull request, the fork. This was really, really neat to look at. Okay, Odin. Man, this is an interesting one. So Wizzymore, thank you Wizzymore, created an Odin port of my ADL. So we're going to look at the Odin code and try to make sense of it. So if you have written Go and you've written Zig, my takeaway from the little I've looked at Odin, just little, is that it should be fairly straightforward to read. Especially also if you have a C background, that probably makes it even easier. So there's not really anything going on here. curious, did he add a, no, okay, there's no Odin version from ASDF. So let's take a look. So there's an http date.odin and a main.odin. Let's look at http date and get an idea of what's going on here. So we have, it's part of our main package. We're importing format, time, and date time from core. There's a procedure that is defined here called get http date. It takes in an allocator. It defaults to the allocator on the context. Okay, I can't teach you Odin because I don't know Odin well enough to teach you Odin, and that's way outside of the scope of this video. I will talk about this, though, because this is one of the things that makes Odin interesting, and actually one of the things I don't like about Odin. So there's an implicit context whenever you call something, and there's also an implicit allocator. So that allocator is the one that's on the context. So if you need to do allocations and you don't change anything, you're going to use the implicit one. However, you can pass in your own allocator whenever you would like. The same is true with that context. So if you change anything on that context, set properties on that context, and then continue calling methods, they'll pop up on that context. So it's essentially a context that you have from Go, but it's implicit in every single method call. And that sounds really nice when you look at Go code where everything, the very first parameter of everything you pass in is a context, but I just don't like implicit things. And that makes me kind of frown upon what I've seen from Odin. That being said, I totally see why people would like that, and it still seems like a very powerful language. It's maybe just not my favorite. Okay, this procedure returns a string. We call time now and store that in now. We call time to date time on now, and we convert that to a date time. We have a static, looks like a static variable in this case here, and it looks like a slice of strings. Sorry if slice is not the correct term. Odineers, Odinists, whatever Odin developers are called. It's not a language I'm super familiar with. But we essentially have the weekdays, and then you have the months, and then we are getting the ordinal from the date, and then the day of the week from the ordinal, and then we're doing some print formatting with all of those things to essentially format our dates the way that this Zig datetime library does that for me and Zig. Cool to see someone actually write this out on their own, and also it's only 47 lines, which is not bad. And let's be real, a lot of the lines are formatting. Okay, with that out of the way, let's take a look at main.odin. All right, so we have a main package here. We're importing format OS2. I'm not sure what happened to OS1, but we're importing OS2. Core slice, core strings, core time. This is interesting. This is what made me want to make sure we talked about the Odin one. This program contains memory leaks, but in Odin, this is not a problem. Because the program is not long running, it means we will never allocate too much memory. And in Odin, the memory is freed automatically by the default allocator when the program exits. So for small programs like this, it is not a problem and is faster to not deallocate. So there's this load call. This looks like a macro. I don't know if it's a macro or not, but it looks like one. And it loads some contents into memory, I would assume, at build time. We read a file if it exists. So again, we have another procedure here. It takes in a file path and an allocator. However, it defaults to the context allocator. And it returns data and an OK Boolean. So you can see here, we have bytes and an error that we're getting from OS2 read entile file from path, passing in the allocator in the file path. We check if the error is not equal to nil. Nice little Go idiom here. And then we set OK equal to false. And then we set our data equal to string bytes. So this is really interesting. So there's a scope right here, right? We don't declare a variable for OK or data until here. However, they're defined in the return type. So what I believe you're able to do here in Odin is you say, I'm returning data and it's a string. I'm returning OK and it's a Boolean. And then whenever you assign those down here, those values get returned whenever you do an implicit return like this. Or sorry, not implicit, but a valueless return. Rebuild readme is another procedure. It takes in an allocator, defaults to the context allocator. You can see that that is also setting the allocator on the context right here. So if you pass in, regardless of whether you pass one in or not, it's setting it. But the idea here is essentially if you were to pass in a new allocator, it would set it on the context so that future things using it would use that allocator instead. It really seems like to me with Odin, one of the things that the developers saw the designers, language designers saw, and I could be wrong on this. This is just speculation. Was context being used in Go and allocators being passed around as the first parameter in Zig, and they were like, "How do we like that? But how do we make it so you don't have to do it every single time?" And again, the implicitness is just not something I care for. Syntax wise, I actually like the language quite a bit from what I'm seeing, but we can talk more about that as we go. So template contents here, we're reading file if it exists, or else readme contents, so the one that gets embedded at build time. If this fails, I don't know. Excellent. So we get HTTP date. We do some string replacement here, very similar to what we're doing in the Zig version in rebuild readme over here. We get all the files in the ADR directory. We format. We have a formatted files. Looks like slice that we're making. We sort those files that we have, and then we append the formatted name to formatted files. We join those with line breaks for markdown formatting purposes, and then we do another replacement here where we're replacing contents with the actual contents. Doing an OS2 open, so we're opening that file with create, write, and trunk flags. If we have an error, we're panicking because we can't open it. And then we're deferring closing it. Kind of interesting. I would expect to see this right after 58, in between 58 and 59, but I digress. And then we write the bytes. And kind of interesting, so there's this transmute method, and my understanding here is that the transmute takes in a type and essentially defines a way to type coerce the thing that you pass into that with the type that's provided to it. So we're transmuting with contents to a slice of bytes. Generate ADR is another procedure here. So we have a number and a name, just like we do in the Zig version here. So there may be different orders in the Zig version. And then also we have an allocator. So kind of interesting here. It looks like allocator is, since it's optional, it tends to be passed at the end, which is the opposite we have in Zig. So I guess not to pick on Odin, but I don't know what the goal is, but my assumption is that it's to avoid passing allocators around as part of the arguments to functions. Yet we have that defined right here at the end. And I guess this is a one-off case, but I think we also do it up here. Yep. And maybe in a couple more cases. So kind of interesting. Again, I'm not an Odin expert. Okay, same thing where we're assigning the allocator on the context to the one that you pass it in. We're doing some replacement to generate a safe name. I think this was before we added extra characters to our safe name logic here. So they're just converting strings to hyphens, which is totally fine. Aprintf to do 0 padded integers for the number that we pass in. And then also printing the file name. Same thing with the heading. We read the file if it exists, or else we use the embedded contents. We do a string replace all with name to replace the name template piece with the heading that we have generated. OS2 open to open that file name, create, truncate, and write. If there's an error, we also panic, defer closing that, and then we write those files, again, transmuting those to a byte slice. Establish core files. So we have another procedure here. This just goes through, uses OS2 to make a directory and checks to make sure that if the error is not equal to nil, and the error is not that it already exists, then we panic. Same with the templates here. Same with the README. We kind of take the same approach here. Defer closing it and then write those bytes. Get all files in the ADR directory. Again, we make a, this is really interesting to me. So this is a slice. Dynamic, I guess, implies that it is a slice or resizable array. I'm not entirely sure on the Odin side what that is, but we do pass in an allocator to it. So it does make me think that maybe this is a resizable array and the type is a string. We open the ADR directory. If there's an error doing that, we panic. We defer closing it. We have a slice of OS2 file infos that we're going to be working with. We read all of the directory into F right here. And also capture an error if the error is nil. If the error is not nil, we panic. And then we iterate through the file infos. So for each file info, if the name is readme, assets, or templates, we don't append it. Otherwise, we do. Then we return the files. So the main procedure here, we have an action, which is a string. We look at the length of the OS args. We grab the appropriate one if there is one. Otherwise, we set it to an empty string. We switch on the action here. So you either have create, which does the creation logic, regen, which does the regen logic, or a default case, which does the help printing logic. This is really cool. This is actually one of the simplest Odin projects I've seen, and it's easy for me to learn from this because I wrote the Zig version, so I know exactly what it's doing from a business logic perspective. So it's cool to kind of pick this apart and look at the differences between the two, and then also just kind of learn more about the language. In full transparency, Odin was one of the things I was considering looking at instead of Zig about 8 months ago. And I ended up with Zig as my choice, which I'm still very happy with, but it's kind of cool to see what this project would look like if I had taken a different route and decided to do it in Odin. Okay, we have one more to go through. I know this video is going on for quite a while. I was also thinking about maybe writing this enclosure in Dart myself to have a couple more to compare. So if you want to see that, let me know in the comments below. And then if so, I might end up doing that as well. Okay, this one was wild. So Das Basti humbled the heck out of me by reminding me that my entire program could just be a shell script. So that's what we're going to do. We're going to take a look at the shell script that he has here. And as he said, rewrite it in bash. So I don't think he updated the README for anything. Does not look like it. So let's just take a look at it. Okay, so the embedding is done inline, which is totally fine. This is a nice helper to keep it out of the source file, but at the end of the day, like, this is not that much different than this. It's totally fine. I think personally for me, the thing I like about having them separate is that whenever I open this template file as Markdown, I get really nice editing experience in NeoVim. And if I were wanting to edit this as Markdown, I wouldn't get the nice editing experience here. Outside of that, there's literally no difference. Okay, so we grab the README contents. Also, before we get into this, I'm not a shell expert or a bash expert. So I will probably misspeak on some of these things. Bear with me. I will try to walk through it to the best of my ability. We grab the README contents and we're catting that. We're taking essentially everything that we have here and catting it. And that's what's getting stored in the contents. So we're doing the same thing down here for ADR contents and the same thing for help contents. We're getting all the files in the ADR directory. So we're creating looks like a list in this case. We're using glob matching or glob pattern matching here on the directory structure to select all of the files that match this pattern. So in /ADR, ***. So in our case, we're grabbing all those files and then we're doing this. So we're getting the file name, which is the base name of the file. And if it's README, assets, or templates, sorry, if it's not README, assets, or templates, then we're adding it to files in the ADR directory. Rebuild README here essentially checks to see if this exists, I believe. Then cat that into a string. So cat is essentially reading this, right? So cat will go in and read this file contents and then store it. And we're storing it here in a string. But the idea here is since we have a $sign and then we have a command in the parentheses here, it will execute that command and then store the response in template contents. So we try to load that, and if we can't load that, then we default to README contents, the one that is embedded, so to speak. We do some date time formatting here. This is actually really, really interesting. I've never done date time formatting in Bash, so this was kind of cool to see. So you can see we have LC time is equal to C, the time zone's UTC, then we get our date, and then here's the format that we're working with right here. We do some output manipulation with sed. So we're taking the timestamp mustache template style thing, replacing it with date. We're using G to replace all occurrences. There should only be one, but I guess that's technically not true. With the users being able to define their own template, there could be many. So this is a good move. Okay, we call get files in the ADR directory. And then we iterate through those. So for all the files in the ADR directory, we have one called ADR file that we're binding to. And we do the following. So we're adding some contents and we're adding a line break for each of those. I actually don't know what this does. This is kind of interesting. So it looks like we're reassigning contents. This looks like sorcery to me. I'm assuming the -2 is having us go back a little bit. So we're maybe removing the last two characters, which would be the /n, which makes sense. But I don't think I've ever seen this in Bash before, so this looks like sorcery to me. Again, with the output, we're using sed to do some string replacement. So we have contents. We're replacing that with the actual contents that are generated as a part of this program. And then we are taking that output and then piping that into the ADR README. Generate ADR is essentially, we have an argument here. Our first argument is the number. Our second argument is the name. We do some numeric padding. Every single language we've looked at has something for this, from what I've seen. Maybe PHP might have had a package that that individual wrote for this, but I could be wrong. Or maybe just a package that they've used for other things and not wrote for this. But Odin, Go, Bash all have ways to do zero padded numeric formatting, which is really nice to see. We generate the heading, which is the padded nums in the name. And then we check to see if the templates exist. If so, we load the user template. Otherwise, we default to the embedded template. More string replacement with sed. More string replacement with sed. This one's removing wonky characters and replacing them with hyphens. So we have the same thing down here. It's kind of interesting to see. This and this are doing the same thing, which is pretty wild. And then we have the file name here, which is ADR padded num safe name, and then we echo the content to that file name. Establish core files, make dir p on ADR assets, ADR templates, and then we echo the README contents to the README. Nice and easy, very, very straightforward. Our main method here checks to see, this also looks like sorcery, but my understanding here is essentially if we're not passing in enough arguments, then we echo the help contents and exit with a 1 status code. If the arguments are greater than 0, then we case off the first argument, which is going to be the command, whether it's create or regen. So you can see here we're casing create, and then interesting. We do quite a few things there. I'm not sure what shift does, so we'll come back to this in just a second. Regen does the same, follows the same pattern, I should say, where we check if that is the value and then do some things. And then same with anything else that we catch is echoed unknown command, then the command name, then we show the help contents, then we exit 1. I don't know what shift is. That's interesting. I've also never seen this. And if you haven't caught on yet, I don't write a ton of bash. So yeah, so there's shift, and then we grab the name and we shift again. If there is not a name, then no name is supplied for the ADR. Command should be ADL create in the name of the ADR. Otherwise, then we exit. Otherwise, we establish the core files, generate files in the ADR, generate ADR, grab the, looks like the number, and then the name itself, and pass that into that generate ADR method. Then call rebuild the README, and then exit with a 0 status code. Regen is similar. We shift, establish core files, rebuild the README, and then exit with a 0 status code. This was humbling, to say the least, to see that my Zig project that I was pretty excited about is 129 lines of Zig or 144 lines of Bash, which is quite interesting. And then if we were to remove the contents, it's actually even fewer. So that 144 lines of Bash is actually significantly less if we were to remove all of the embedding type template stuff that is hard-coded here. Okay, that covers the ones that we have. So thank you, Das Basti, for humbling me with a really involved shell script. That was cool to see. I mentioned potentially maybe rewriting these myself in Clojure or Dart. Those are two other languages that I find really interesting. Dart's not anything wild. Clojure is a little more wild. But if you want to see that, let me know in the comments below. Also, like, keep doing it. I'm going to be really selfish here, but I think this is awesome to be able to go through and look at a project that I've built and I'm familiar with and see how it's implemented in other languages. It's a great learning opportunity for me. I also think it's a great learning opportunity for you, hence the reason this is the second video on this topic I've done. So yeah, if you haven't yet subscribed to the channel, we're all friends here. I love talking to every single one of you, and I would love to do it more. I also told a friend of mine that if we ever got to 5,000 subscribers, we'd start a Discord server and have a way to communicate more freely. We're really close, which is shocking. I didn't think we'd hit this point, but I'm so excited and proud that we have. So let's get to 5,000 and I'll share that Discord server, and I would love to talk to you all more frequently. Outside of that, I think I just said subscribe to the channel. I think that's everything. If you liked the video, give it a thumbs up. And if you didn't like the video, that's okay. I get it. I hope you still have a great day. Thanks.